Here's the update on the Cadillac. I didn't have the cooling issues resolved the way I had hoped that I had. The only testing, aside from road testing, that I did was just running it in the shop here and allowing it to get warm, and then raising the RPMs and just, watching the temperature fall, which was suitable for just idling and sitting in the shop here. But the other day I took it for a spin down the road, and I was perhaps too confident in the fixes that we had made to the Cadillac itself, and wasn't paying as much attention as I should have to the temperatures, and I was getting on it pretty good. And by the time I realized it was getting hot, it was too late, and it was getting real hot. I ended up having to park it on the side of the road and walk home and grab my truck and trailer for a rescue mission. While the new parts that we've put in are definitely better than the old parts that they replaced, they didn't fix the underlying issue, obviously, of the Cadillac's overheating. And I've arrived at the conclusion that it has to do with something like this. When I was throwing it back together after I put the water pump and radiator on it, I had this 195 degree thermostat, which is not usually what I run, but the diameter of it was the right size for the relief in the water pump housing. It's not in the water pump housing, but in the block there. So I just use this thermostat here. The problem is there's a bypass in the coolant system that allows coolant to basically stay in the block longer, heat up faster before you actually open the thermostat. And the passage, once the thermostat opens, ends up getting blocked off, so that you have full circulation of fluid through the block and the heads. And this isn't the exact thermostat for the application, but it looks a lot more like this than this. It has a flat plate on it that, as the thermostat opens, this plate drops down and plugs that bypass, thereby forcing all the coolant to run its normal course through the block, through the heads, and then back through the radiator. So without blocking that passage, even once this thermostat opened, you were basically just bypassing in the very front of the block and heads. The coolant would go into the block, but immediately up through the heads and back through into the water pump. So that is the next fix that I'm hoping will work, because the engine has been overheated a number of times. I elected to tear it all down, and I brought the heads to a machine shop for them to magnaflux and make sure that we don't have any cracks in the heads. which would definitely contribute to an overheating and situation where you're pushing all the coolant out of the overflow. So the heads are at the machine shop right now. They're going to check them for cracks and then actually see if, measure the deck or the head surface to make sure that it's still flat after all the overheating. I don't imagine it'll be a huge problem, as the stock Cadillacs had kind of a fail-safe built into them that actually only killed the engine at like 260 degrees, which would necessitate, I think, the 16-pound cap on the radiator in order to reach that temperature without completely boiling over, but that's beside the point. So, heads are at the machine shop. I've got a new proper Cadillac thermostat coming that's 180 degree. Would have been nicer to get 160, but 180 will be better than nothing. And with the proper style, hopefully we get the proper circulation through the head and block, and we don't have any more overheating issues. Along with ensuring that the heads don't have any cracks in them and that they're still flat, I've pulled the grill off here, and I'm going to have to rework the, I don't know what you call it, baffling, in order to ensure that at highway speeds all the air that is passing through the grill actually passes through the radiator also. There are quite a few open spots to either side of the radiator, and then the entire bottom isn't covered, and with the intercooler providing its bit of resistance, it just exaggerates the flow of air, probably going around the radiator itself and not passing through at highway speeds or speeds other than you would expect the fan to pick up the slack. It was I just assumed that the cooling of the radiator would be good enough without all that, so I left it out. My bad. So we'll be reworking some items to ensure that as much airflow as possible is passing over that radiator and not just bypassing it around the edges. With effectively the short block still sitting in the car, you can see we've got it torn down, and my convolution of oil passage and feed devices. This is running to the electric oil pressure gauge, and this is actually a nitrous tea that I found that was adaptable to the oil pressure galley, and then just equipped it with some 3AN fittings in order to run my two lines to the turbos. I do have a couple oil feed restrictors on order in order to install on the turbos, because there are times when the engine temperature gets up and the engine or the oil gets hot, where I see really low oil pressure, which obviously I'm not a fan of. It could be an effect of the fact that we've got this feed teed off right before the pressure sender is there, so it may be kind of an erroneous oil pressure reading. But if the turbos don't need as much oil as I'm sending them, I'm more comfortable restricting the feed to the turbos. And actually, in the long run, I'd rather burn up either of those turbos than this engine. It was always kind of sacrificial. Like I said before, this engine here came out of a 75 Coupe de Ville, and I don't know how many miles that vehicle actually had on it. I imagine it had quite a few more than this chassis here. When I got this Cadillac, it actually only had about 58,000 on the odometer, while the 75 that I yanked this motor out of had seen use all throughout the years up until I got a hold of it. So it probably had 100, 150 plus on it. The one thing is you can see that it's not mechanical scoring, but it's something you can see with the eye. We no longer have the nice crosshatch that you'd like to see in a cylinder, but none of them are gouged. So we'll end up buttoning this back up and running it for all it's worth before I either take this one down and rebuild it with some better rods and pistons, or I actually have an earlier 500 Cadillac, but the only problem is it has the head difference between the years is quite extreme as far as the size of the combustion chambers and the mixing and matching of pistons to get a workable compression ratio. But drained the oil down shortly after I pulled it all apart, and no large amount of metals came out of it that I was able to see. I laid a magnet at the drain point just to see how much it would collect, and it wasn't really that much, unless everything just pooled in the oil pan and didn't flow out when I drained the oil. So after disassembling the engine, I was able to see just how well we were sealing around on the exhaust side, the hot side of the turbos. And there were definitely a few leaks and a couple gaskets, my homemade gaskets anyways, that were burned through. So I ordered some proper copper gaskets. When it comes to high heat on the exhaust side, I prefer copper just because it doesn't generally burn out like a graphite composite type gasket, where they'll get a leak that eventually just burns everything out. Copper is obviously real good at conducting heat, so they don't burn out. You may still have a pinhole, but it doesn't enlarge from there. And then I've got these proper wastegate gaskets. I had actually made my own, but they didn't have this embossed raised ring, which is probably what failed, and I had one that burned out in the lower quarter of it. But along with the other usual resealing items, an intake manifold gasket, and in place of the, I had originally built the hoses for the turbo oil supply, but at one point had one of them come loose at the fitting that I had, or the connection that I had made. So instead of worrying about that all the time, I went and bought these. They're basically brake lines, but they have obviously a much better construction, much more rigid construction at the joints here. So these will be a weight off of my mind when she's up and running again. Upon disassembling the heads before I sent them off to the machine shop, I noticed some kind of irregular carbon deposits and basically heat, indications of heat on some of the different valves. These, the main ones that caught my eye would be the number 1 and 2 cylinder exhaust valves. If you can see, very, very white, not too unlike a spark plug that is getting hot. And then you can see this one here, and then the others have the general soot pattern on them. I think I might have got a little oil on that guy. But these two are definitely, I mean, to me, and I don't know a whole lot about valve appearance diagnosis, but it would seem that these were getting hotter than the others. I could be wrong, obviously. But then there is kind of the non-uniformity between the intake valves. Like, we've got plenty of carbon buildup on this guy here, and then we've got halfway around, and then it's warm, and this one is odd, like it's seen, I don't know, enough gas to wash it off where the others haven't. And this one's pretty okay. And actually all the intake valves on this head were, I mean, nothing that stands out. It's just kind of this side, which would have been the passenger side head. I don't know if we're seeing reversion, where we're actually getting some exhaust, or, you know, an unusual amount of heat up into these cylinders. I just don't know. The cam in it, or obviously these springs came with the cam that are in the engine right now, and the damper that is in these is pulling the oil seals up off of the guide, and I'm wondering if I can get away without the damper, because most all these seals were sitting a good half or 1 inch up off of the top of the guide itself, where it comes through the top of the head. I haven't had any oil burning issues as far as that goes. So, but then again, this engine hasn't seen a whole lot of use since I had the valve work done to it. So it could be a result of that. I'll have to talk to the machinist and maybe see if I can get away with pulling this damper out of here and just running the spring itself to where it's not scraping the seal up off of the guide. As you can see, there's definitely been a bit of exhaust leakage. These are the exhaust manifold gaskets. They don't come in a single piece. They're 4 individual gaskets for each header, but from the bright spots you can see where it's sealing, and then obviously in our 4 corners there we're losing gases, and most of the others show a lot of the same indications of leakage. So I have the other set of these, and in my hackery I am going to reuse the old guys and sandwich another gasket on top of it, and hope and pray that that additional width in the crush will allow these to seal completely, or better than they were anyways. Then we have our spark plugs, which none of them show any signs of over hot exhaust temperatures. They don't show any signs of detonation, and they could be a little bit cleaner, but the Phytech ECU hadn't nearly worked out its algorithms for the AFRs. So at the point that it, or the amount of time I had given it to become accustomed to the engine it was on and the demands put on it, they actually look pretty good. In addition to addressing the overheating issue of the engine, while I have it in the shop, I'm going to have to fabricate a skid plate for the transmission pan. With the drop that I've got on the springs, and then the slightly lower profile tires, the clearance between the transmission pan and driveways, concrete driveways up and in, and then just the suspension experiencing full travel, I am leery of not protecting the transmission pan. If you look straight across the frame, the pan actually sits a good 1/2 inch to 3/4 below the level of the frame. So she's going to hit before the frame will pick up the slack. I'm probably just going to get myself a piece of 1/8 inch steel plate, cut it to the correct dimensions, and then just self-taper screws on the frame itself and bend it up around just past the transmission pan, just behind the bell housing or the torque converter cover on the transmission itself. I'll show you some pictures of that once it's installed, but all I've got right now is measurements, and then I still have to go to the steel store and get a piece of plate